Namaste bachcho. Today in this lecture we will discuss about the question and answer given in your main exercise of first chapter. Questions are already with you. I have already sent in the group. Today we will discuss about the answer. I have written only answer here. Okay, I have not written the question. Question is already with you, so we will see here the answer one by one. Question number one is convert the following temperature to the Celsius scale. See, it is given here 293 Kelvin. To convert this into Celsius, we subtract the given quantity. We subtract 273 from 293 and we'll write in such a way. Under bracket 293 minus 273 degrees centigrade, and the answer will be 20 degrees centigrade. Okay. The process of writing should be such a way. Okay. Then only you will get the full marks. And second also same thing. Same question is here. To convert 470 Kelvin into Celsius, we subtract 273 from 470 and we will get 197 degree centigrade. In this way, we will change Kelvin to Celsius scale. Second one is to convert Celsius to Kelvin. To convert Celsius to Kelvin, we add 273 in the given quantity, that is temperature. See here, in 25 degrees centigrade, we add 273 and we get the result 298 Kelvin. Means 25 degrees centigrade is equal to 298 Kelvin. Similarly, 373 degrees centigrade, here also we will add 273 and write in this way and we will get the result 646 Kelvin. Okay, so it is a very important question. Number 1 and 2 is very important because one question is always asked in examination in this conversion, either from Kelvin to Celsius or Celsius to Kelvin. So we'll take it very seriously. Now third question, give reason. A. Naphthalene ball disappear with time without leaving any solid. Naphthalene ball disappear. See, naphthalene ball is very common to us. We use in our daily life, in our houses, as a disinfecting agent. Actually, naphthalene ball is sublime material. Okay, so due to sublimation, it disappears. The main reason is what here? Sublimation. Here, naphthalene ball changes from solid to gas directly without heating, and this process is called sublimation. It takes some time, but it convert from solid to gaseous form due to the nature's heat. Okay, no extra heating is required from outside. So the answer is here, due to sublimation, naphthalene ball convert solid to gaseous state directly. Second one is we can get the smell of perfume sitting several meters away. See, the smell of perfume we get from several meters away. Here the reason is diffusion. The particles of smell the particle of perfume mixes with the air and it is called diffusion, and due to diffusion we get the smell of perfume from several meters away. Here the diffusion is very fast because the particles of perfume are also in the gaseous form and they mix with the air, means both are in gaseous state and the diffusion is very fast. The reason is what here? Diffusion again. Okay, so I have written in short form only, I have written in symbolic form only, not in detail. In first question due to sublimation and second question due to diffusion. Okay, now fourth question. Arrange the following substances in increasing order of forces of attraction between the particle, uh, that is water, sugar and oxygen. Three type of substances are given here: oxygen, water and sugar, and we have to arrange them in increasing order of their attraction among the particles. See, we have already studied that solid have maximum force of attraction, liquid have less attraction than solid, and gaseous matter have negligible force of attraction, means the attraction between the particles. Here oxygen is in the form of gas, water is in the form of liquid, and sugar is in the form of solid. So, and this gaseous matter has maximum force, minimum force of attraction, and water has more force of attraction than oxygen, and since sugar is solid form, so and this matter has the maximum force of attraction among the particles. So in this way we will arrange them. Okay. Now question number 5. What is the physical state of water? See, there are three temperatures given. A, it is 25 degrees centigrade. Question is that at this temperature, what is the state of water? So naturally, at this temperature, water is in liquid state always. Okay, so it is in the liquid state. In the case of 0 degrees centigrade, see, in this case, water is present in both solid, that is in ice form, and also in liquid state. Actually, this temperature is a transition state. Means at this temperature, water starts freezing. Okay. So at this temperature, water is found in both for solid as well as in liquid state. It is also called transition temperature. Okay, means at this stage water is in transition state. Similarly, in third, 100 degrees centigrade. Here also water is present in both for liquid and in gaseous state. See how? Because we know water starts boiling at 100 degrees centigrade. So the part of water which has no latent heat of vaporization, that will be in liquid form, and the part of water which has latent heat of vaporization, that will be in gaseous form. So at this temperature also water is found in both states, liquid as well as in gaseous state. Okay, it is also called the transition temperature for water. Okay, because at this temperature water is found in both states, liquid as well as in gaseous state. Now question number 6. Give two reasons to justify the answer. First question is, water at room temperature is a liquid. Water at room temperature is a liquid. See, room temperature means temperature near about 30 degrees centigrade. At this temperature, water is a liquid because it has tendency to flow. Okay, means water will flow at this temperature. It will behave like a fluid, and it has no fixed shape. At this temperature, if you will see, water will have no fixed shape. Means where it is kept, it will take the shape of that container only. So these two conditions or regions show water is present in liquid state at room temperature. Second, an iron almirah is a solid at room temperature. See, for this very common reason is there, at it has fixed shape and volume. At this temperature, at room temperature, almirah is also found in almirah has a fixed shape and volume. Okay, and it is hard and rigid. See, the condition is mentioned here at room temperature. So it is very important because alumina is made of iron and it can also be melted into liquid form. But it is strongly mentioned here at room temperature. So at room temperature, it will not melt and it will remain in a fixed shape and size and volume. So it is solid. Okay. It has hard and rigid structure also. That's why. Now number 7. Uh, why is ice at 273 Kelvin more effective in cooling than water? At 273 Kelvin, it means at 0 degrees centigrade. See, uh, it is already answering this statement, means this question is already answering the uh, C part of question 5th. In question 5th it was what is the physical state of water at 100 degrees centigrade, and here it is written why is ice at 273, sorry not C part, B part. Why is ice at 273 Kelvin more effective in cooling than water? Means at 273 that is equal to 0 degrees centigrade. Means at this temperature both form of water is possible, that we have already mentioned here. Now this question discuss that why at this temperature ice is having more cooling effect than water. Means at this temperature water is present in both form, liquid as well as in solid form. Liquid form is water itself and solid form is ice. Question is that at this temperature ice has more cooling effect than water because water has more energy than ice. We have discussed in the previous class about latent heat. Means when ice is supplied with extra energy, that converts into water. Means ice plus latent heat of melting is equal forming water. Means water is having latent heat, that is called extra energy. So at same temperature ice has more cooling effect than water because water has more energy in the form of latent heat, or we can say ice has less energy than water. So ice cause more cooling effect. Question number 8 is similar like of 7. What produces more severe burn, boiling water or steam? See, boiling water and steam both are there at 100 degrees centigrade. Okay, so steam has more energy than boiling water because steam takes latent heat of vaporization. So steam has more energy than that of boiling water. So steam will cause more burning effect than boiling water. Okay. So in these cases, in both 7 and 8, the reason is almost same. The reason is latent heat. Means steam has more energy in the form of latent heat. So it will cause more burning effect. And in the previous question, water was having more energy due to latent heat. So ice was causing more cooling effect. Okay. Now question number 9. A diagram is given here, and we'll have to write the name of A, B, C, D, E, F, S should be answered here. It is shown in the question. We'll see. See here, solid converts into gaseous state, and the process is called sublimation. Solid to liquid is done by melting. Liquid to gaseous state is done by vaporization. Gas to liquid is done by condensation. Liquid to solid is done by freezing. And gas to solid is also called sublimation or deposition. Means here at A position we'll write melting, at B vaporization, at C condensation, at D freezing, at E sublimation, and at E we'll write deposition. So in this way we'll mention the diagram. So this is all about the question and answer of this chapter. Thank you.